Epilepsy is defined as a series of neurological disturbances such as loss of consciousness, convulsions, sensory disturbances, and loss of muscle control. Epilepsy occurs when there is an imbalance in excitatory and inhibitory neurotransmitters. The excitatory neurons are upregulated and the inhibitory neurons are downregulated, causing excessive electrical signals to fire in the brain.
GABA is synthesized from glutamate, which is also the excitatory neurotransmitter in the central nervous system. GABA stops the neuron from firing, while glutamate elicits an excitatory response.
While there isn't a specific, known reason that epilepsy occurs, there are important neurotransmitters that have been shown to be imbalanced in people who have epilepsy.
GABA is the chief inhibitory neurotransmitter in the brain and has a calming effect on the central nervous system. Its chemical formula is C4H9NO2. GABA is an amino acid neurotransmitter because it is structurally an amino acid but has an inhibitory action in neurons.
The GABA-A receptor is split up into 5 different subunit proteins that receive several different chemical signals such as GABA, benzodiazepine, neurosteroids, barbiturates, and several others. When the neurotransmitter meets the receptor, there is no formation of chemical bonds, but instead it changes the conformation of the receptor. This mechanically shifts the protein subunits to allow negatively charged chloride ions to pass through the central pore. This hyperpolarizes the cell and inhibits the firing of new action potentials, thus inhibiting the neuron.
The GABA-B receptor is metabotropic and also works to hyperpolarize the cell. It does this by indirectly linking GABA to the potassium ion channel via the G protein. It signals the channel to allow the outflow of potassium ions to hyperpolarize the cell and inhibit the firing mechanism of the neuron. GABA is commonly sold as a supplement with the goal of utilizing it in the brain, but medical opinion says that GABA in its supplemental form does not reach the brain and will have no effect other than a benign placebo.
Common treatments for epilepsy include a class of drugs called benzodiazepines, which attach to the GABA-A receptor and produce the same inhibitory effect. These can be taken long-term to reduce symptoms of epilepsy and can be administered during the seizure to help end the episode. Benzodiazepines are also used to help treat anxiety disorders, sleep disorders, and schizophrenia.